Hello everyone, welcome back to my channel. This is Shravya. I'm currently pursuing my BE second year in Sri Venkateswara College of Engineering, Bangalore. In this video, I'm going to discuss about the subject data structures. In that, my topic is stack and stack operations in data structures. In that, first we have to discuss about introduction to stack in data structures. In that, a stack is a linear data structures that follows in the last in first out. That is LIFO principle. We call it as LIFO principle. It is an abstract data type with two main operations such as push and pop. In C, a stack can be implemented using arrays or linked lists. You can see this in the picture. When we push the item, it goes to the top to bottom and it goes to pop item. When come to the stack operations, push operation adds an element to the top of the stack and the pop operation removes an element from the top of the stack, and peek operation retrieves the top element without removing it from the stack. We have push, pop, peek and is empty and is full. You can see that in this picture. Next come to the implementing stack using arrays. In that, create an array of fixed size to represent the stack and then it initialize a variable to keep track of the top elements as index. When we push operation increases the top index and adds the element to the array. Here we have that when we enter the numbers, it decreases the one by one into the n numbers. When we come to the stack overflow and underflow, we have that stack overflow occurs when the stack is full and push operation is performed. And the stack underflow occurs when the stack is empty and pop operation is performed. And the proper checks should be implemented to avoid this error. You can see this full stack and empty stack. We have full stack means this is mean push and the empty stack is pop, that is underflow. And now implementing stack using linked lists. In that, create a structure to represent each node of the linked list and then initialize a pointer variable to keep track of the top node. And push that operation creates a new node and updates the top pointer. We have here stack and array. When we come to stack, it increases. When we come to array, it decreases. Now come to time complexity of stack operations. In that, we have push and pop operations in a stack that implement the using arrays have a time complexity of 0 of 1. And push and pop operations in a stack implemented using linked lists also have a time complexity of 0 of 1. And the peek operation has a time complexity of 0 of 1 as well. You can see the time complexity in this image. We have average, worst, access, search, insertion, deletion, access, search, insertion, deletion. When we come to array, it updates 0 of 1. When we come to stack, it's 0 of n. When we come to queue, it's of e of n. When we come to singly linked list, it has 0 of 0. Double linked list means e of n. Skipper list means we have e of log of n hash table n comma a. When we comes to binary search tree, we have e log of n. When come to the Cartesian tree, it have n comma a. And like that we have B tree, red black tree, splay, AVL tree and KD tree also. Can see the space complexity and worst also here. When we come to the advantages of using a stack, here we have a image that shows the advantages. In that we have simplest one, insertion deletion from one place to another place, and it is easy to implement and it's fast operation. In that, efficient insertion and deletion at the top of the stack, easy implementation and understanding of stack operations, and these all can be used in various applications like expression evaluation, backtracking and full function call management. When we come to the disadvantage of using stack, we have the image. In that we can see that some of the advantages, that is on it. Let me see the disadvantages. Only can be inserted or removed from the top, and recursive function it get problem when accessing the one that on the top. And we have a limited capacity when implementing using arrays, and we have dynamic memory allocation required for stack implementation using linked list, but it is not suitable for applications requiring access to elements in the middle. When we come to the applications of stacks, here the image, we have application of stack, that is push, pop, and top. When we insert all these top, push, and pop, we get data 1, data 2, and data 3. In that, infix to postfix conversion and evaluation of arithmetic expression, function call management in programming languages, and undo and redo functionality in text editors and graphic software. Thank you.